All right.
Love it.
Now, who has found something on Prequest number 3 that if I handed this to you right now and said do these problems, you would not be able to do?
1 through 7.
Okay, I'm not going to do 1 through 7. I need you to pick one.
1, 2D, H, 2H.
2H. All right, let's start with 2H. 2H. Where's M? Okay, so M is up here.
I think of 2K. 16.
M is the vector -1, 2. And our job, you said H, we want to find a vector in the same direction as M. So in other words, it moves the same way, has the same slope, but we want its length to be 3. All right, what's the length of M right now?
1, 2.
Well, it moves left 1 and up 2, so envision that triangle. How long is it? √5. The magnitude of that vector is √5. So I need to make it a length of 3. So who remembers how to do that? We've done this before. What? So, no, I don't divide it by 3. I divide it by its magnitude. So I divide by √5. So now I have this vector, which is how long? If I divide by its magnitude, I am creating a unit vector. So this guy is 1 unit long. How long do I want him to be? 3. So all I'm going to do is times him by 3. So your answer is -3 over √5, 6 over √5.
Easy one.
So you can make a vector have any length you want it to have. This one happened to be 3. You can have any length you want by making it a unit vector first and then multiplying it by the desired length. So how do we make it a unit vector? We divide it by its magnitude, period. And then multiply it by whatever you want. All right, so that was 2H. All right, who else sees one that if you had to do it right now, you wouldn't be able to? Which one? 4.
It's the easy money stuff.
4 is a work problem. We've done one already, but I'm sure there'll be one on the test. To find the work, remember, we take force times distance times cosine.
What number is this?
This is number 4.
Thank you.
All the information is in the problem. Sometimes you just have to dig for it a little bit. The force is 15. It tells you that. It's a 15-pound force. Do I know the distance? 10. We're going from 0, 0 to 10, 0. So the distance is 10. Do I know the angle? No, but I do know that the angle is in the the vector is in the direction 1, 3. This is the angle, and I can find that by simply second tangenting 3 over 1. So that angle is 71.57. So now I need the cosine of that angle. So now I'm just going to take 15 times 10 times cosine answer, and I got 47.43 foot-pounds.
Love that. I love when I get this right. I love when I get on 21.
All right. Too sharp. 5, a Cartesian equation is simply an equation with just x's and y's. So in other words, we need to get rid of the parameter.
Where's Cartesian?
Now, 5 is a little bit harder than the one we did on the other practice quiz, because this one has sines and cosines in it. That makes it a little harder to get t by itself. Remember we got t by itself and then plugged it in? When you put sines and cosines in there, that's a little bit harder. But we did one. Who remembers? What was our strategy? Well, personally, I like to divide first. You do not have to do this, but I like to do it. It's a personal preference of mine to get the sine and the cosine by themselves. Then what? Square. If we square everything, perfectly legit, we're just squaring both sides. And now I add my equations together up and down. I'll have x squared over 4 plus y squared over 4. That's what's on this side. Equal to, what's this? 1. Here's your answer. Notice that the t's are gone.
Can you leave it in that form, or do you have to take it? Do you have to?
No, that's fine. It's a circle, so normally the 4 would be over there, but the directions just said write a Cartesian equation. So that is all there is to it. That's a little bit more tricky than the other kind. All right, who else looks at this paper and thinks, oh my gosh, if she asked me to do that right now, I couldn't do it. Number 1?
No.
Number 1 is exactly like the one we just did, except it's easier.
So all we have to do is like get to like the substitute and you get the answer.
You just want x's and y's, no t's. 6? 6 is like the one we just finished. We got some random points.
I love you. I love 6s.
And we want to find the measure of angle C. So that's the first part of the question. Find the measure of angle C. Alright, well you can't do that until you figure out what the vectors are. The vectors that make angle C are CA and CB. That's the beginning of the problem. Groupies, if you use any other vectors, you will not get the right answer. If you want angle C, you must be using CA and CB. So, what are the coordinates of CA? -1, 9. What are the coordinates of CB? 3, 8.
Let's go.
So now we have the coordinates of the vectors. That is step 1. Now, what do we do with those to find the angle? We just did it. We find the magnitudes. We need the magnitudes. So the magnitude of CA would be the square root of 82. And the magnitude of CB would be the square root of 73. So we know we're going to multiply magnitude times magnitude times cosine. And what's that going to equal? The dot product, which is
9 plus, no, -9 plus something.
69. -3 plus 72. So I'm going to go ahead and multiply those two radicals together. Oh, I swear we did that. So 69 over the square root of 5986 equals the cosine of C. And then I can find my angle by second cosining.
Let me tell you what the negative is.
I got 26.9 basically.
The area is square root 19. No, it's divided by 2.
Alright, so everybody got the angle?
Yup. I know the area.
Then the second part of the question, this seems to be a common theme, is find the area. Since you already have everything you need, the area could be calculated by 1/2 square root of 82, square root of 73, sine 26.9.
Yeah, 9.9.
Okay.
No.
Can we just do the little
And
square
it could
thing?
also be calculated -8
Plus 27.
minus 27, so negative 35 over 2. When you type all that in, you should get 17.5.
Oh. Well, so it's always, that's right.
Is it negative 17.5?
No, it's 17.5 to make it positive.
Oh,
If I
yeah,
put the vectors in the other order, it would come out fine. All right. Who else? Now we've done that twice in the last, 20 minutes. We've done this probably twice. We ought to be good at that. All right. What else? Read down through all those questions. What are you not going to be able to do? 2E. First of all, you treat the absolute value symbols, which are the magnitude symbols, you treat those like parentheses, so you're going to evaluate everything in here first. So we're going to forget about those for a moment, and we're going to evaluate this. So that'll be 3 times 3, 4, minus 2 times negative 1, 2.
So we have 9, 12.
So we have 9, 12, minus negative 2, 4. So now I'm going to subtract those. So 9 minus negative 2, and 12 minus 4. Now I want the magnitude of that, which would be 121 plus 64, the square root of 185, which doesn't break down or reduce anything, but that would be the answer. So we do all the arithmetic first, and then do the magnitude when you finally get everything combined.
Absolute values are like the magnitude.
That means magnitude.
Brain gets censored. That works.
All right.
Next year we'll have some more brains.
Who else? Look at the entire list. What else do we need to talk about that we haven't?
The one after, number 3.
Number 3.
Nice pick.
Well, we kind of talked about this already, but it was in a much harder problem. Find the components of the vector. So this is like the airplane flying out here at a speed of 10, an angle of 37 right there. What do we mean by components? X and Y. So we're just going to make a triangle. And remember that the triangle you make is always your butterfly bow tie triangle, just like before. That never changes. So cosine 37 equals x over 10. So x is cosine 10 cosine 37, and y will be 10 sine 37. And we just type them in, and your answer is this. It's an x and a y. So 10 cosine 37, 7.99, and 10 sine 37, 6.02. All right. What else?
I actually like this.
Which one?
2K.
2K. Trey kind of told us about this a minute ago. We want to find any vector that's parallel to negative 1, 2. This is 2K. Any vector parallel to that, all you have to do is what? Pick a number and multiply it by something. So
-2.
if you want to, yeah, I mean, -2,4, if you double it. How about -1020, would that work? You can multiply by whatever you want. Yep, you can multiply by
10,
anything.
negative 20.
You can do fractions, radicals, decimals, anything.
I'm gonna make mine the biggest number possible.
All right.
Something just in
Multiply by 1,000.
1,000, 2,000.
Who else? Let's get as many done as we can. What else on here are you not prepared for?
We haven't 2F yet?
2F. I know we did not do 2F. We've actually done it twice today, but not this particular problem.
Let's do it again.
M has coordinates -1, 2, and N has coordinates 3, 4. So here are your two vectors, and you want to find the angle between them. So how do we do that? How do we find, what does it take to find the angle between two vectors? It takes the dot product. So the dot product of these would be
-3 plus 8.
5.
5.
So it takes the dot product. If you want to find the angle between two vectors, you need the dot product. What else do you need?
Magnitude.
The magnitude. So the dot product is going to equal the magnitude of this vector, which is root 5, times the magnitude of this vector,
28.
which is just 5, times the cosine of the angle between them. So 5 over 5 root 5,
Just 1 over 5.
and that's just 1 over root 5. So I can go to my calculator, and second cosine, 1 divided by the square root of 5. I got 63.43 degrees. So, what does it take to find the angle between two vectors? It takes the magnitudes and the dot product.
And so I suppose
If you are given points to start with. Now here we were given the vectors, but in the triangle problems, before you do anything, you've got to create the vectors, and then you do magnitudes and dot product. Right? Okay. Next time I see you, we're going to have our quest over 6-1 to 6-3. So that means the review is due that day. Now wait, there are 2 review assignments you have to have done, and one of them I just did for you.
What's the other one?
So you have 1 more to do, and you have 2 days to get it done. And it's good practice for you. I mean, the whole idea is you need to practice on your own, right? So Prequest 1 is on your own. It is on video. So if you get stuck, you can get on video and get unstuck. Okay? All right. I will see you. I will see you tomorrow in 2 days.